Hello children, in this chapter of squares and square roots, part 7, today we are going to learn about some more interesting patterns of doing our calculations faster and also about Pythagorean triplets. So we are going to learn finding squares of a number without actual multiplication, without multiplying actually. That means square of a bigger number. We know that square of the smaller number can be found easily. We can remember also 2 square, 3 square, 4 square, till 20 square it is easy to remember. After that, it becomes difficult. We have to multiply. Suppose square of 39 or square of 45 into 45, we have to multiply. So without actually multiplying it, how can we find the square of a bigger number? There are two methods and you can use any method you want, but mostly I will be using this method, that is a plus b the whole square. That identity I will be using it. Now the first method, I will explain both the methods, but I will be following, we will be doing this method in our exercise also. So a plus b the whole square. You have learned this in your 7th standard expansion chapter. It is a plus b into a plus b. So first term is multiplied with the second bracket, that is a plus b. And the second term of the first bracket, that is plus b along with its sign, plus b into a plus b. And a plus b the whole square, we know the identity a square plus 2ab plus b square. And if you have forgotten, learn this identity. Both the identities will be very useful. We also have one chapter based on these identities. So learn this identity, a square plus 2ab plus b square. Now using this, both the identities, how will we find the square of the bigger numbers? So find the square of the following numbers without actual multiplication. This is example 1 of your textbook, and I'm going to solve 39 with using the first method and 42 using the second method. Then you decide whichever method you find it easier, you can do it. So 39, first of all, I will represent 39 as 30 plus 9 the whole square. Now this 30 plus 9 is also written as 30 plus 9 into 30 plus 9. Now the first term of the first bracket, that is 30 into 30 plus 9 plus 9 into 30 plus 9. Now this 30 is multiplied with this whole bracket. This means, so 30 into 30 is 30 square and 30 into 9. So plus 30 into 9, because there is a plus sign in between. So plus 30 into 9. Now plus, so plus sign in between, and 9 into 30. So 9 into 30. Plus sign is in between, so plus, and 9 into 9 is 9 square. I repeat, first you multiply this 30 with this whole bracket and plus 9 with again this bracket. Then we remove the brackets. So when we remove the brackets, this 30 is multiplied with this 30 also, and then plus this 30 is multiplied with 9 also. So 30 into 30 is 30 square, and because there is a plus sign here, so plus 30 into 9 is 30 into 9. Then plus sign here, so plus 9 into 30, and again plus 9 into plus 9 is plus 9 square. Now because 30 square, there is 1 0, so the square will have the double. So 1 0, so those becomes 2 zeros, and 3 square of 3 is 9. So 900 plus 30 into 9 is 270 plus 9 into 30 is 270 and plus 9 square is 81. When we add all this, we get 1521. 1521. Now the next method. Next method is 42 square. So see here 42 square. Now first I will represent, this is same for both the methods, 40 plus 2 the whole square. Now consider this as your A and this as your B. So square of the first term, A square is 40 square plus 2 into 40 into 2. 2 into 40 into 2, so plus 2 square. So 40 square is 1600. 10, so 0 becomes double. So double 0 and square of 4 will be 16. Now here 2 into 40 is 80 and 80 into 2 is 160. And square of 2 is 4. So you get 1764. Once again I repeat, a square of the first term, so square of the first term plus 2, always plus 2 into first term into second term. So 2 into 40 into 2 plus square of the second term. Here second term is 2, so plus 2 square. So that is 1600 plus 160 plus 4, which is equal to 1764. Now, how to find square of the numbers which are ending with 5? So, let's see that. To find the square of the numbers ending with 5 without actual multiplication, this is very, very easy. See, 25 square. Now, we know that 5 square is 25. So, we just write down plus 25. And now this 2. The number after 2 is 3. So 2 into 3 into 100. Always 100. 2 into 3 into 100. So plus 25. So that is equal to 600 plus 25, which is 625. Another 35 square. Now the number which comes after 3 is 4. So 3 into 4, preceding number. So 3 into 4 is into 100. The number which is after 3. So 3 into 4, which is 100. Sorry, it should be succeeding number. So 3 into 4 is into 100 plus 25. So it is 1200 plus 25, which is 1225. Now 75 square. So the number which comes after 7 is 8. So 7 into 8 into 100 plus 25. So that is equal to 5600 plus 25, which is 5625. One more example we take. 125 square, which is equal to, now this number 5 square, the number before 5 is 12. Just we will not take 2. Whichever numbers are before 5. So it is 12. So 12 into 13 into 100 plus 25. Now 12 into 13 is 156 into 100 is 15,600 plus 25. So it is 15,625. One more example we take. 95 square. 95 square, the number which comes after 9 is 10. So 9 into 10 into 100. So 90 into 100 is 9,000 plus 25. So that is equal to 9025. One more we take 105 square, which is equal to 10. Now number before 5, they are 10. So 10 into 11 into 100 plus 25. Now 10 into 11 is 110 into 100, which will be equal to 11,000 plus 25. So 11,025. This is one method and this is another method. Here 75 square. So number after 7 is 8. So 7 into 8. And then 5 square means 5 into 5. 7 into 8 is 56. So it will be 20. And here it will be 25. merge the numbers. That is 5, 6, 2, 5 is the answer. See here also 5, 6, 2, 5. Suppose I take 125 square instead of 75 square. So 12 into 13 is 156 and 5 square is 25. Merge them, so you get 15625. So any method you can use, but I find this method easier. So this is the method you will be using to find the square of the numbers ending with 5. Now another interesting concept of Pythagorean triplets. Now Pythagorean triplets. Now this word Pythagorean, it sounds very familiar, isn't it? Yes, it sounds familiar with Pythagoras theorem. You may not have learned Pythagoras theorem, but you will be learning it, and this Pythagoras theorem is very, very famous, and it is used in so many fields, and even in architecture, construction, everywhere it is used, this Pythagoras theorem. And now what are these Pythagorean triplets? And how are they related to Pythagorean theorem? That we will come later on. Let's see. What are Pythagorean triplets? It's a collection of 3 numbers. It's a collection of 3 numbers. That the number triplets itself tell you that there are 3 numbers, such that the sum of the square of the 2 numbers is equal to the square of the third number. Now what does this mean? Sum of the squares of the 2 numbers is equal to the square of the third number. Let's take one example. 3, 4 and 5. Now 3 square plus 4 square should be equal to 5 square. Then only they are said to be Pythagorean triplets. So 3 square is 9 and 4 square is 16. 9 plus 16 is equal to 25, which is correct. So 3, 4 and 5 are called Pythagorean triplets. And here each number 3 is called the member of the triplets, Pythagorean triplets. 4 is called the member of the Pythagorean triplets. 5 is called the member of the Pythagorean triplets. Now suppose I take another example, 6, 8 and 10. So 6 square, I want to find out whether. Now 6 square plus 8 square is equal to 10 square. You know that this is the bigger number when you are watching here also. See, bigger number. So sum of the 2 smaller numbers should be equal to the bigger number, square of the bigger number. So here also 6 square plus 8 square is equal to 10 square. 36 plus 64 is equal to 100. So 6, 8 and 10 is a Pythagorean triplet. They are the Pythagorean triplets. Now how it is related to Pythagoras theorem? Of course it is not in your syllabus at present, but let's take a look at it. Pythagoras theorem is that it says that in a right angled triangle. So in a right angled triangle, this is a right angled triangle. The square of the measures or sum of the square of the measures of 2 sides forming right angle. So this is the perpendicular and this is the base. So sum of the square of this side, which is forming a right angle. Which are forming a right angle? One line which is perpendicular and this is the base. So we call that p square plus b square should be equal to the square of the hypotenuse. Side opposite to the right angle is called hypotenuse. So here also in this right angle triangle also they follow the rule of Pythagorean triplets. That is p square plus b square is equal to h square. That means square of the side, length of the side which is perpendicular plus the square of the length of the side which is the base. I call this p and I call this base. So p square plus b square should be equal to h square. So this is what the Pythagoras theorem says, that the sum of the squares of the 2 sides forming a right angle should be equal to the square of the hypotenuse. So this is the height, hypotenuse. And so they follow the same pattern as the Pythagorean triplets, and hence the name Pythagorean triplets. Now, which numbers can be a Pythagorean triplets? If we know one number, one member, can we find out the other members? Yes. If I know only one number, 3, can I find out the other numbers? Yes, I can find out the other numbers. Why? Because I know this rule. For any natural number n, and n should be always greater than 1. The Pythagorean triplets are of the form 2n, n square minus 1 and n square plus 1. They should be of the form 2n, n square minus 1 and n square plus 1. Let's take one example so you will be more clear about this. But you have to remember that the Pythagorean triplets are of the form 2n, n square minus 1 and n square plus 1. Now, as we solve the examples, you will be more clear. Let's see. How to find the Pythagorean triplets when one of its member is given, when one of the member is known. So, we'll take one example, and this is example 2 of your textbook. Find the Pythagorean triplets whose smallest member is 8. Now, here the smallest member means this. 2n is the smallest. So, now in Pythagoras triplets are in the form 2n, n square minus 1 and n square plus 1. We know that. So, we will assume let 2n be equal to 8. Because you are given that the smallest member is 8. So, 2n is the smallest member and that will be equal to 8. So, n is equal to 8 upon 2. I will first find the value of n. So, that is 8 upon 2 which is equal to 4. Now, I want another number. So, therefore, n square minus 1. That is 4 square minus 1, which is equal to 16 minus 1, and that is equal to 15. And the third number is n square plus 1. So, I will write down n square plus 1. Now, what is n? 4. So, 4 square plus 1, which is equal to 16 plus 1, and that is equal to 70. So, thus the Pythagorean triplets are 8, 15 and 70. Once again, we know that the Pythagorean triplets are of the form 2n, n square minus 1 and n square plus 1. So, first we will assume that this 2n is equal to 8. From that, we will get the value of n. So, n is equal to 8 upon 2, which is equal to 4. Now, from that, I will find this number, n square minus 1. What is n square minus 1? So, I will substitute the value of n. Instead of n, I will write 4 square minus 1. 4 square is 16. 16 minus 1 is equal to 15. The next one is n square plus 1. Now, n is 4. So, 4 square plus 1, which is equal to 16 plus 1, that is equal to 70. So, the Pythagorean triplets are 8, 15 and 70. That is the value of 2n, value of n square minus 1 and n square plus 1. Let's take another example to be more clear. Find a Pythagorean triplet in which one of the member is 12. So, we will always assume let 2n, smallest member is 12. So, let 2n will be equal to 12. It is not given smallest member is 12, but we will assume that 12 is the smallest member. So, 2n is equal to 12. So, we will get the value of n. Yes, n is equal to 12 upon 2, which is equal to 6. Now, the next Pythagorean triplet is n square minus 1. So, n square minus 1 is equal to 6 square minus 1, which is equal to 36 minus 1, and that is equal to 35. Now n square plus 1. I can directly write n square as 36 because I know 6 square was 36. So I will write 36 plus 1, which is equal to 37. So the Pythagorean triplets are 12, 35 and 37. It is 12, 35 and 37. Once again I explain, whichever member is given, you assume 2n is equal to 12. So from that you will get the value of n. Then put the value of n in n square minus 1, which is 6 square minus 1. 6 square is what? 36 minus 1, which is 35. Now n square plus 1. N square is 6 square and 6 square is 36 plus 1, which is equal to 37. So these are the Pythagorean triplets. What is the value of 2n? 12. So one member is 12, another member is 35 and the third member is 37. So the Pythagorean triplets are 12, 35 and 37. Children, in the next part, we will be doing exercise 6.2, which will be based on these Pythagorean triplets and how to find the square of a number without actual multiplication. So, see this video again if you have not understood. Be very clear before we start with the next part. So, till then, stay home, stay safe.